Hello and welcome to another video. Today we're going to show you how to vacuum test and if necessary ream the bore of 700R4 pump pressure regulator valve. So we're going to actually test both the boost pressure regulator valve and the TCC apply valve circuitry so that we can get a full understanding of the condition and health and state of these bores. Now this is the what I refer to as the combined hydraulic service station. It has the ability to both test as well as repair via reamer anything that has valve trains. So anyway, before we get started, you want to make sure you calibrate your machine. So what you want to do is take your test lead and insert it here into the calibration receptacle, and then when you do that, you're going to turn the vacuum pump on, and you want to see a steady 5 inches of vacuum here on the gauge. And let me get that so you can see it. Alright, so when you have 5 inches of lift, you're going to come over here and you're going to locate the calibration port and plug it with a finger, and then that will cause the needle to jump up. It'll probably land somewhere between 20 and 30 inches. You want to adjust your valve so that it's reading a steady 25 inches. And then when you take your finger off, you want it to drop back down and read a steady 5 inches. So on the machine itself, you have two valves. You have your bleeder valve and your pump valve. All right. The pump valve has a lead that goes right to the air pump, and then your bleeder valve is going to correspond to the test lead, which of course is now in the calibration receptacle. So when you turn the machine on, you're going to use the pump valve to adjust your initial calibrated vacuum to get it to 5 inches. And you're going to turn it counterclockwise to increase the vacuum signal, and clockwise to decrease it until you get on that 5 inches and keep it there. When you plug the calibration port, you're then going to turn to the bleeder valve, and you're going to adjust up and down counterclockwise and clockwise until you get to 25 inches. And then you take your finger off. If you still have 5 inches consistently, you've basically calibrated the machine for use. You have to do this every single time, otherwise you run the risk of having inaccurate and unreliable results when you go to do your testing. Alright, so let me go ahead and calibrate the machine, and then we'll begin the testing. Alright, so we're just shy of 5 inches, so we'll go counterclockwise, make our adjustment. Now it's at a steady 5 inches. Take our finger, plug the port. Now we'll adjust our bleeder valve to get us to where we need to be. Alright, here counterclockwise decreases the signal, clockwise increases it when you're adjusting on the high side. Alright, so a little bit off, about 4 3/4. Now we're at 5. And we are now 25. Back to 5. And we are good. Alright, so you're going to test at the following locations here on the stator support. And this is going to apply to 204Rs, 700R4s, and 4L60Es. So right here is going to be your balance spool for your pressure regulator valve. Right here, this kind of oblong, roughly arrow-shaped channel, or maybe it looks like a fish. This is going to be your boost circuit. Right here is going to be your inboard test location for your apply valve for the torque converter clutch. And then right here is going to be your outboard test location, this little orifice. And when you test this orifice, you want to put a finger here. And that will seal off the entire circuit in this location so you can get a valid reading. Alright, one thing you need to do before you test the PR valve is you need to get that little orifice in the valve exposed and then plug it with a pencil eraser. Okay, I have a few other videos on the channel where I show this. And so, we're going to more or less follow the same procedure here. Alright, we'll go ahead and remove our test lead. And we'll install it into the test block, and then we'll use the gasket to seal the circuit off. Alright, this this hose is kind of ungainly. I want to make sure I'm not obstructing the view of the gauge, so I'm going to go ahead and turn the machine back on and then we'll begin. We want to see a minimum of 15 inches of vacuum on all working valves. That is our threshold for serviceability. Alright, so when you first put the block at this location, you're going to get either 0 signal at all, or maybe at most 2 or 3 inches. So now what you need to do is plug the little hole, and we're getting 12 inches of vacuum. Alright, 12 inches. Alright, now we're going to go ahead and test our boost valve. Okay, that's the fish-shaped channel here. Alright, now when you do this, you need to plug an orifice on the other side of the pump. And that's one of these, and as you can see, I did not have this fully covered. Make sure it's fully covered. And that's your orifice right here. So you can hear it. Alright, we are reading at 6.5 inches of vacuum. And that's 6.5 inches. Alright, obviously that's no good. Alright, now our inboard torsion, or circuit rather, for the TCC apply valve. Want to make sure that's in view. And you also have to plug another orifice. It's going to be right here. This isn't too bad. It's at 15. Get that to focus. Not too bad. Now we're going to go ahead and test the outboard location, and we need to plug the front with a finger. Alright, so right now if you don't plug it, you're only going to get a partial signal, 10.5. Go ahead and insert a finger and push inboard just a little bit. Get it to the regulatory position. And you'll see we're at, and it looks like 17. Yeah, I'm going to call it 17. Alright, so for background, this is the Nemesis. You know, the now infamous 700R4 that I took in, that was previously remanned by a relatively well-known large-scale remanufacturer of these units, and it claimed to, you know, in their advertising, they claimed to be a 500 plus capable horsepower transmission. So we saw in the teardown inspection video and the follow-up deep dive video that that was very far from the truth, and so now we're going back with it. And I probably should have led with that in the beginning of the video, but that would have made too much sense, so I'm mentioning it here. I mean, it's in the title, so you already had a, you know, kind of an inkling as to what was going on. Alright, now one other thing I'll mention is Sonnax recommends you test all the bores dry. Okay, in my experience, there isn't really much of a material difference at all. Any discernible difference, frankly, if you test dry versus if you assemble all your castings and, you know, put all the valves in using WD-40. It is not recommended that you test these things when you pull them out of the transmission. They're still filthy dirty. There's more than likely tons of grit and grime circulating throughout, and some of it's undoubtedly, you know, getting caught up here in the valve trains and the bores, and that could potentially throw your reading off. In other words, that some of that crud and sludge is actually sealing the bore to an extent, and you know, as a result, you might think that the casting is in good shape when in fact the bore is actually worn. So you always want to clean these parts off thoroughly. You know, put them through the cleaning cycle, reassemble them, then test them when they're all nice and clean like this. So let's take a look at the results. All right. The TCC apply valve inboard and outboard actually passed. We're still going to put a Sonnax valve in here anyway. It's a high performance unit, you know, going in behind a 383 making 450 horse. So we want to shore up all circuits and make sure that we're good to go in that respect. The pump pressure regulator valve is 12. Okay. For a purely factory application, especially if somebody was on an extreme budget, this is not necessarily the end of the world. If you had this reading in a 4L60E, you can install the Transgo drop-in pressure regulator valve. This should bring it back up to about 15 or so, and that's where you want to be. In my experience, drop-in valves are worth between 3 and 5 inches of vacuum in terms of your gains. If this was like 8 or 9, which I initially tested this, and that's where it tested. So I don't know, maybe there's a little bit of variability, or maybe I didn't calibrate the machine, I don't know. But point is that if this is like in the single digits, you need to ream the bore. So, you know, offhand, I don't know if there's a drop-in pressure regulator valve. If they're, you know, I briefly looked and I couldn't find one. I thought Superior Tech made one. Maybe they do. I just, you know, my hard part supplier here in town couldn't get it. They weren't aware, they didn't have any listing in their catalog. So, you know, but anyway, the boost valve is 6. Obviously, that's no good. We're going to put a Sonnax O-ring half-inch boost valve here, and that will, you know, straighten that out. All right, I gotta take this thing back apart, get all the valves out, and then remove the stator from the support itself, put it in the fixture that you know, this fixture here, so that we can ream it and install the Sonnax oversized valve. So after we ream it, I'll put it again through the cleaning cycle, make sure all that those all the shavings or whatnot are out of it, and then from there we'll go ahead and reassemble and retest. So a couple things worth mentioning real quick. This is true of all 3 of the transmissions, you know, that are kind of under discussion here, the 204R, 700R4, 4L60E. So you have 2 areas of vulnerability here in the pressure regulator valve. You have the balance spool, and then you have these 2 lands. Okay, if these 2 lands are aggressively worn, then you're going to have repeated 3/4 clutch pack failures. It's actually one of the kind of under the radar drivers of why that clutch pack fails so much in these transmissions. Okay, for the 204R, it'd be the direct clutch. If the balance spool end is bad, I mean really, really bad, like, you know, single digits of vacuum, then you actually run the risk of having the rotor and slide break up and fail. Okay, irregularities in the circuitry between the pressure regulator side, boost circuit side, and the, you know, working portions of the pump, you know, the rotor and slide pocket, will occur if you have a really worn balance spool. So whenever the pump fails in a given 4L60E, 700R4, what have you, 204R, you really want to vacuum test the stator support, because if you're in the single digits, then that's basically the direct cause of your pump failure, because these pumps don't actually fail for no reason. they either fail upon installation, somebody just fails to catch the torque converter slipping ever so slightly off the rotor where it's only partially engaged. These things will still bolt up. It'll look correct. Everything will appear to be fine. When you fire it up, the the hub will destroy the pump rotor and you'll have no movement whatsoever. The other cause is, of course, worn PR valves in transmissions that come in for overhaul. So they have a lot of miles on them. Always check, via your vacuum. And it's also worth doing a visual inspection as well, so that if you see signs of wear, like we see on this valve, I mean, you can see the wear here. You can see it here on the balance spool end as well. All right, see that wear? You absolutely do not want to reuse this as is.
Okay, now we're going to go ahead and ream the bore. So if my voice sounds muffled, it's because I'm wearing a respirator. And I'm wearing a respirator because the cutting fluid that I'm using stinks. And it's probably mildly poisonous. And if you're around it and you breathe it in, not more than about maybe 60 seconds or so, and you're going to be a little dizzy. So respirator helps me kind of, stay focused and not kind of fumble around with stuff because I'm dizzy. So anyway, let's talk through what we're going to do here, and then we'll go ahead and do it. So the reamer we're going to be using for this bore, and this is going to be for 704s, 204Rs, and 4L60Es, is going to be the Sonnax 77917-RM2. It'll come with an alignment sleeve, but it will not make use of the alignment collar mechanism in the fixture. So basically all you want to do is get this thing so it's not in your way, and it's not going to be interfering with the reamer and the sleeve when you insert it into the bore. So here's the bore in question. This is what we're going to ream, this area right here. That's the pressure regulator valve circuit in its entirety. So how you're going to do this is you're going to go ahead and install the reamer into the sleeve just like this, with the step side facing inboard, and then all you're going to do is insert the reamer and the sleeve into the bore until it comes to a stop, just like that. Alright, you want to be careful when you're handling this stuff. You don't want this thing falling on the ground or banging on anything. These reamers are precision instruments, and I mean you guys know this, you don't need me to tell you. If you bang it and the blade gets nicked up, then it's basically no good, and these things are not cheap. They are not cheap. I think this one was about 250 bucks or something like that, plus tax. Alright, so let's talk about the tools you're going to need to do this. First and foremost is a good quality drill. Okay, it could be battery powered, it could be electric or air. Doesn't really matter as long as it's capable of high torque and slow to moderate speeds. So this is a Snap-on, Milwaukee, DeWalt, Makita, take your pick, whatever you want to use. As long as it's capable of high torque and low speeds to moderate speeds, you're good to go. Alright, the next things you're going to need are a wobble extension, just like this. You want a wobble. For this reamer, a 7mm conventional socket and a 1/4 to 3/8 adapter. And you want to install it so that it wobbles just like this. This will allow the reamer to continuously self-center even if you're slightly off kilter when you're performing the ream. Lastly, you want a 3/8 adapter chuck for your drill so that you can use the drill with the extension in the socket. Alright, so now what we're going to do is take the casting, stick it on the fixture, okay, line it up, make sure that you have unobstructed access to the bore, and make sure it's perfectly flat. I mean, this is kind of eccentric. So whenever you're dealing with something like this, first off, I should have mentioned this initially, make sure you remove the alignment pin for the stator. Okay, that cannot be in there if you're going to use this fixture. Now Sonnax does make a fixture specifically designed for reaming pump bores. Okay, it's it's got a giant cavity here. It's a little bit wider, or actually a lot wider, and it'll allow you to keep the stator installed and ream the bore for whatever pump you need to ream without having to separate anything. But I don't have that, so this is what I'm doing here. All right, now we'll go ahead and we'll grab our reamer and our sleeve, and we'll go ahead and insert it so that we can perform the ream. Just get it in, fish it through. All right, make sure it's not encumbered in any way, shape, or form. Okay, make sure that your opening of your alignment collar is not interfering. And then what you need to do is you need to clamp it here to the fixture using some sort of intermediary. I got a big old aluminum block. These are available on Amazon. They're all different shapes and sizes for like, I think this one was like $6, maybe $7, something like that. So what you want to do is situate it over here. You absolutely have to have your circuit that you're reaming, your bore, exposed with the worm tracks facing up. All right? You have to make sure that you have access for your cutting fluid distribution to continuously lubricate that bore and the reamer during the reaming process. Now, Sonnax tells you that they designed the fixture and all the rest of this equipment to work with just one clamp. And that's fine if you just want to use one, but I prefer to use two. I prefer to use two because I want to make absolutely sure that this thing's not going to move on me when I'm reaming it. You know, when I'm reaming the bore. You don't have to get super tight. You don't have to crank down on it to, you know, any kind of crazy extent. It just can't move. That's it. So I'm going to bring in a supplemental clamp. And I'm going to clamp it over here. Let me clamp it here. Now, let me move this. I'm going to push it to the left just a little bit because I see I got a little bit of interference here. So I'll see if I can move this collet just as far right as I can get it. And now I'm going to push the casting to the left, maybe about ½ inch. All right, that's good. All right, make sure it's solid. And it's these kind of little setups and adjustments and checks you want to do before you start reaming. Because once you start reaming, that's it. You know, you're pretty much committed, and you got to go for broke at that point. Okay, make sure that your clamps are not making any contact either with the casting. Okay, you just want them to hold straight up and down, and you don't want any clamping over the circuit you're reaming because that might distort the bore and cause it to go out of round, and your ream will not be successful. All right, now that the reamer is in there, you want to move whatever distribution mechanism you have in the dispenser right over the reamer so you can saturate it and the bore with cutting fluid. And it's always good to have a flexible hose like that because you could, position it every which way. Now this is going to take, I don't know, maybe 20 or 30 seconds to actually push all the fluid up from the tank below so it starts coming out of the nozzle here. I'll cut most of that out, obviously. I mean, who the hell wants to, just stare at this thing while the fluid's waiting to spool up. Get plenty of cutting fluid all over that reamer and the bore. You want it saturated. So now go ahead, get in position. Do one final check, make sure that there is no tension anywhere, and then go ahead and begin the ream. Once you think you're bottomed out, then stop and then start to withdraw. Do not reverse. Alright, now I'm going to take it out, clean it up, and then we'll go ahead and insert the Sonnax oversized valve and vacuum test it to see if the repair was successful. Okay, moment of truth. So here's our oversized pressure regulator valve. And we're just going to drop it on in. Kind of get it aligned. It should fall into the bore all the way to the bottom, largely under its own weight. There, you can check. Alright, it's bottomed out. And it just so happens I have the little orifice there exposed, so I don't have to monkey with it using the pliers. So that's our location for test. I'm going to fire up the vacuum test machine, and I'm going to make an adjustment for calibration. Alright, I think we're good. Alright, between 15 and 20 inches is ideal. For a little higher than that, that's not the end of the world. If we're significantly higher, then we may have to polish the bore. Which again, no big deal. Alright, so it's pulling, looks like about 2 inches or so with the orifice unplugged. Plug the orifice and it's kind of tight in there. Alright, looks like we're at 22 and a half. Alright, so we're a little on the high side. It's not the end of the world, but what I think I'm going to do, I'm going to polish the bore just a little bit. I don't want this valve hanging up when it goes back in, because we're testing this dry. Like Sonnax has you do. So if we're dry at 22, it's probably going to be a little tighter than that when we have, fluid in there and it's working. So I'm going to go ahead and polish that, then we'll retest. If I can get down to like 20, then I think we'll be ready to move on. Okay, let's give it another go and see what kind of reading we get now. Let me turn the machine on. Alright, pulling some vacuum. Not as much as we were initially, so that's good news. Alright, so it looks like we're about 20 1/4. Let me zoom in, see if I can do this. I gotta take my hand away. I'll zoom in. You can see the gauge itself. I don't know how visible it was prior. Alright, so right at 20 inches, that is perfect. That's what we want. So I'm going to go ahead and reinstall the stator, and then we'll move this over to the assembly station where we can start putting it all back together. Alright, that is this video. If you guys want me to, let me shut this off first. If you guys want me to, you know, kind of go through this entire setup, you know, how I put it all together, and, you know, show you all the parts and bits that you would need to replicate it, let me know and I'll do a separate video on that. I mean, basically you have a sink, you know, stainless steel sink, a large enough workbench to have a variety of items on it like you see here, and then you're going to need a little parts washer of some sort, and that has to be positioned below so that you can pipe fluid up through to your dispenser and lubricate your reamer and your workpiece. But I mean, that's the long and short of it. But like I said, I'll do a more in-depth video, and we'll, you know, get you everything you need: dimensions, parts, tools, and other whatnot. So that wasn't really the focus of this video. This one was just focused on repairing, reconditioning the pressure regulator valve bore in this 700R4 pump. So as always, guys, thanks so much for watching. Greatly appreciate it.